This is continuing 3.2, and we are going to work on the two proofs in 3.2. It's super important that you draw the proofs into your homework so that you can write on them. And it's also a great idea to have a couple of colored pencils or highlighters or pens and pencils, things of different colors, so you can help yourself see what you need to see in a proof. Proofs are all about vision. Now, we worked from day one on if I give you a statement, what can you conclude? And that was getting you ready to do proofs. So we always make our big T-chart and we write down our given, that NQ bisects angle MNP, and angle NMQ is equal to angle NPQ. That is our given information. If we are given anything directly that's equal, like we are in that second piece, we go to our picture and we mark it. So I'm going to mark those base angles right now. Now, what does the given give me? That NQ bisects MNP. MNP is bisected, and it goes that way. If I remember my definition of bisector, that means it cuts it exactly in half. So that means that angle MNQ is equal to angle PNQ by definition of bisector. That's what that piece of given gives me when I'm working my proof. So then I'm going to go ahead and I'm going to mark that angle. Now at this point, if I am trying to prove triangles congruent, I know I have three theorems. I have side, 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 I have angle, side, angle, and I have angle, angle, side. I have two angles. That leads me to believe that I'm either going to use angle, side, angle, or angle, angle, side. And then I go to my picture and I try to see if I can figure out the missing side. There are actually two ways to do this proof. The one that I picked up on first is this right here. I'm always going to look for that reflexive side. And so I can say that NQ is equal to NQ because this is going to be a fold in half and my two triangles share that side, and I can see that from the congruence statement. And the reason they do that is the reflexive side. So now I can say that triangle MNQ is congruent to triangle PNQ by look at my picture, angle, angle, side. Now, some people want to know why we have to write that step 3. Because just like in turn-by-turn directions or a recipe, I have to have an angle, and a side somewhere in my proof. Here's an angle, and here's the side. If I don't write that step, or if I don't write the step 2 from the bisector, if I just assume it, then my recipe isn't complete. Now, another thing you can do is take and trace these in different colors. And when you trace them in different colors, blue and yellow make green. You see that overlap. The other way you could have done this proof is if you look at the big triangle of M, N, P, that the base angles are equal. I could have used the isosceles triangle theorem to say that MN equals PN. Then the triangles would have been congruent by angle, side, angle. Same number of steps. I would have just traded out step 3 and a different reason in 4. The last proof looks scary. We haven't looked at anything with circles, but the circle's really a distractor. Now, so is my typo. But if we look at the picture gives us that NO is equal to QO and MO is equal to PO. So we're going to go with the picture because we know Mrs. Green makes mistakes when she types. And it is important to write your given because it's having everything in the list for you to look at when you're trying to decide what you have or don't have. Now, when I mark my picture, the first thing I think of is two sides. My options are side, 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 or side, angle, side. Those are my only two options. And when I look at NM and QP, I have no way of proving those congruent. Nothing jumps out at me. But what does jump out at me is that right here in the middle, I have two lines that intersect, and if I have two lines that intersect, I always get vertical angles. So I'm going to write that angle NOM is equal to angle QOP by the vertical angle theorem. And when I look at my picture, side, angle, side. My triangles are congruent. Triangle NOM is congruent to triangle QOP by side, angle, side. If you are asked to prove angles or sides, you are almost always, 99% of the time, going to use CPCTC to get it. And when I look at where those angles are, in fact, parts of the triangles that I'm looking at, because the triangles I'm looking at are right here. Here are the two triangles that I just proved congruent. Parts in the blue highlight are corresponding parts of my now congruent triangles, and so I can say angle MNO is equal to angle PQO by CPCTC. Good luck.